Hello everyone. In this video, we're going to focus on logarithms. We're going to discuss about evaluating logarithms, properties of logarithms, condensing and expanding logs, change of base formula, graphing logs, and towards the end, we'll be solving equations using logarithms. So first, what does it mean by logarithms or log? Logarithm is the inverse of exponential function. As an inverse of exponential function, it can undo exponentials. This means that we can use log to solve exponential equations. In other words, logarithm is the exponent or power to which a base must be raised to yield a given number. Expressed mathematically, x is the logarithm of n to the base b if b to the x is equal to n. So that is expressed in exponential form. B to the x is equal to n. As in logarithmic form, this is log of n to base b equals x. So b is the base and x is the exponent. And n is what we call the argument of the logarithm. And here, b and n must be positive integers or positive numbers, and b cannot be equal to 1. Otherwise, an exponential function does not exist. As I have mentioned earlier, that logarithms is the inverse of exponential functions. So this means that we can use logarithms to solve exponential equations. So let's see how that works. See, we have an equation over here. That's 3 to the power of x is equal to 24. So how are we going to solve the value of x, the exponent of 3 in here? We all know that 3 to the power of 3 is 27, right? And we also know that 3 to the power of 2, that's 3 squared, is 9. And we have here the right hand side is 24. So it falls in between these two limits, right? So it should be in this limit somewhere. So how are we going to solve that exponent x right there? So by the use of logarithm, we can solve for the value of x. So in here, we take the log on both sides of the equation. So since the base is 3, so we use log base 3 of 3 to the power of x is equal to log base 3 of 24. And here, logarithm power rule, we are allowed to put the exponent to the front, and log 3 base 3 cancel each other. That this is 1. So we have just x is equal to logarithm base 3 of 24. So now we can use our calculator to solve for the value of x, right? Without the use of logarithms, we will not be able to solve this kind of problem. Log 24 base 3 can be written the same way as log of 24 divided by log of 3. And now this is what we call the change of base formula. From base 3, we split 24 and 3. We put 3 on the bottom and we make it as log of 3. And now the base is not 3 anymore, but this is base 10. So whenever you don't see base 10 right there, this is base 10. So now we can use our calculator to solve for the value of x. And so we have here the value of x by using our calculator. Since it's gonna be rounded off to some decimal place, so this is value of x is approximately equal to 2.89 and so on. This is just rounded off to 3 decimal places, and this is the approximate value. And if we go to our exact value, this will be the exact value of x. So now that you have basic knowledge in solving exponential equation using logarithms, now we have to go back to our topic and scale back to the basics, so you will gain more understanding of logarithms. So let's start with the transformation of exponential form to logarithmic form, or vice versa. Let's say we have here an example. 2 to the power of 3 equals 8. That's exponential form. And here the logarithmic form, that is log of 8 base 2 equals to 3. So from here, from exponential form, how do we convert it to the logarithmic form? So, and here from the exponential form, we can equate log to both sides of the equation. Since the base is 2, we can use base 2 log. So we have log base 2 of 2 to the power of 3 equals log base 2 of 8. And here, we can take down the exponent to the front as a coefficient. That's a logarithm power rule. We will know that later. So, but since this is just the basics, so I will just show you how to switch log form to exponential form or vice versa. So we have here, taking down 3 as a coefficient, we have 3 is equal to log base 2 of 8. And here, why did we do that? Since the log 2 base 2 is 1, using the same base, so this cancels out, and this becomes 1. So we ended up with just 3, the exponent, and we take log base 2 the same way on the right, so we have now log of 8 base 2 is 3. And now if you take a look at the right, that is the same way written on here, log base 8 of 2 equals 3, right? So we ended up the opposite side of the coin, like on here, to logarithmic form from exponential form. So from the logarithmic form, switching or converting to exponential form, how are we going to do that? So how do we convert this to its exponential form? And so from here, there are 2 ways to do. So we can exponentiate both sides with base 2, right? So we can have 2 to the power of log base 2 of 8. If we do on the left, we do it on the right. So we exponentiate base 2 of 3 over here on the right. So here, since these are inverse functions and the same base, that means it cancels out. So we ended up having 8. So, and the right hand side is 2 cubed. So if you take a look, this is what we had started earlier, right? 8 is 2 cubed. That's the same way. So what about this? This is the exponential form, and this is the logarithmic form. Exponential form, base is e. E to the power 2x equals 2x. Whenever you see e as the base, we'll be using natural logarithm instead of common logarithm. Let's say we have the common logarithm, log of 2, that is base 10. For logarithm of 2 to base e, that is the natural logarithm, it is equal to ln of 2. Since ln is base e, so instead of writing log base e of 2, we have ln of 2. Alright? So now let's go back to our exponential equation over here with base e. So whenever you see base e, we use natural logarithm ln. So how do we convert this exponential equation to logarithmic equation? So here base e, so we'll be using natural logarithm. So we take ln on both sides. So natural logarithm of e to the power of 2x is equal to natural logarithm of 2x. And here ln of e is 1. It cancels each other to 1. So we ended up with just the exponent, 2x, right? So we have 2x is equal to ln of 2x. And how about this? How do you convert this logarithmic equation into exponential form? So we have e to the power of 2x. We exponentiate both sides with base e. E to the power of 2x is equal to e to the power of ln of 2x. And so here, ln up to the power of 2x is equal to just 2x. Since once again, these are inverse functions right here. So ln is base e and exponentiate with base e right there. So this is the exact inverse of each other. So it cancels each other. So we ended up with just 2x. So this is what we have started earlier. And so what about these two sets of exponential form, converting it to logarithmic form? I would like you to do this. So now feel free to pause the video and do it. take it a shot. And so let's start solving. So let's take the logarithm of base 5 on here. Since the base is 5, so we take the logarithm base 5 of 5 cubed is equal to log base 5 of 125. And take down as 3 is coefficient, we have 3 is equal to log base 5 of 125. Since this is 1, cancels each other. So how about here? Converting logarithmic form into exponential form. So here, exponentiate both sides of the equation now with base 5, right? We have done that earlier. So the other way to do this is we take the definition of logarithm. So this is base 5 to the power of 3 equals 125. So this is 5 to the power of 3 equals 125. So that's the other way to solve this, to convert logarithmic form into exponential form. So if you notice, take a look, this is what we have started, right? Okay, so how about the other one? Here, and so here the base is e, so we use natural logarithm. So we take the natural logarithm on both sides times e to the power of 3 to the power of x is equal to ln of 3 to the power of x. Here, ln of e is 1, so we take down the exponent as the front coefficient. So we have 3 to the power of x is equal to ln of 3x. So this is what we have over here now. And how about this one right here? How do we convert it to exponential form? Since we're using natural logarithm, so we exponentiate both sides with base e. Since e correlates to using the natural logarithm, so exponentiate both sides base e. So e to the power of 3 to the power of x equals e to the power of ln of 3x. So we have here e to the power of 3 exponent x equals e to the power of ln. This is base e, so this is the exact inverse of each other, so it cancels each other. So we ended up with just 3 to the power of x. So now let's go to evaluating logarithms. So we have here now evaluating logs. Log base 2 of 16, log base 7 of 49, log base 3 of 27, or we say log of 27 base 3. That's how you say it. Either way, the other way around. So what does it mean if we evaluate logs? So that means all we have to do is find the value, right? Find the value of this expression. So log 16 base 2 asks what is the exponent of 2 to make it 16. So this is the same way being asked, how many times you multiply 2 to make it 16. So if we multiply 2 by itself, let's say 4 times, so 2 times 2 times 2 times 2, that is 2 times 2 is 4 times 2, 8 times 2 is 16. So this is 16, right? So this is 2 to the power of 4 times, right? 4. So the answer is 4. So what's being asked is the exponent of 2 to make it 16. The second one, what's the exponent of 7 to make it 49? Or how many times you multiply 7 by itself to make it 49? So it's squared, right? 2, so that's 2. Since 7 times 7 is 49. And you multiply 7 by itself, that is the exponent 2. How about here? Log 27 base 3. So once again, you multiplying 3 by itself, how many times? That'll be 3 times, right? So 3 times 3 times 3 is 27. So that is 3 to the power of 3. Exponent 3. That's the answer, exponent 3. And so what about these 3 right here? Log of 1 base 5, log of 0 base 10, log of negative 3 base 3. So in here, log 1 base 5, it's asking what is the exponent of 5 to make it 1. So how are we going to do that? So 5 times 5 is 25 already. 5 times 1 is 5. So if we put 5 times 0, that is 0, right? So the answer is 0. Right, since anything raised to 0, so this is converted into exponential form. This is 5 to the power of 0. So let's write over here, 5 to the power of 0 is equals to 1. So that means any number raised to 0 is 1. So that's like 100 to the power of 0, it'll be the same 1, right? So 0. What about this? Log of 0, base 10. So if we convert this into exponential form, we can have this as x as the exponent, so that is 10 to the power of x is equals to 0. So this is the argument, right? So 10 raised to x make it 0. Can we do that? So multiply 10 by itself, it will be 100. 10 to the 1 to the first power is 10. It cannot be 0. So this means this log expression does not exist. So we just put D and E does not exist. And what about this? Log negative 3 base 3. So once again, this is negative. It cannot be a negative in the argument or in the log. So anything negative in the log does not exist. The log expression does not exist. And what about these two right here? ln of e to the power of negative 25 and ln of e to the power of x minus 2. So once again, ln of e is 1, right? So we have just the exponent, that's negative 25. What about this? ln of e to the power of x minus 2. The same way, ln of e is 1, so we ended up with just the exponent. So x minus 2. So what about these 4 log expressions over here? If you notice, the base and argument are perfect reciprocal with each other. And so whenever you see the base and the argument are reciprocal, the answer must be negative 1, right? So that must be negative 1. And so how do we prove that? So let's solve. Let's write it over here. So log base 8 of 1/8. Designate this as x. Here we use the definition of logarithm. That means 8 to the power of x is equal to 1/8. So we have 8 to the power of x is equal to 1/8. So here put 8 to the top. So this is equal to 8 negative 1, right? So we have 8 power x is equals 8 negative 1. The same base. So we can equate the exponents. So x is equals negative 1. So we have here negative 1. How about this? So wrap this over here again. So log base of 1/8 of 8. So designate this as x. So exponentiate both sides of the equation with base 8. I mean base 1/8, right? So we have 1/8 and 1/8 on both sides. So this cancels. So we ended up with just 8 on the left side. And the right side is 1/8 to the power of x. So in here, 8 is equal to, and now we can put 8 to the top again. So that becomes 8 to the negative 1, right? Negative exponent 1 from the bottom. So we're following the exponent formula, that is 1/8 to the m is equal to 8 to the negative m. If we put this element on top from the bottom. And let's go back. Existing exponent is x. So we have 8 is equal to 8 to the power of, we have this multiplied, right? So negative x. So left side is 8 exponent 1. So base are the same. So exponent can be equated, right? So x is equal to negative 1. So here is the answer, negative 1. So what about these two? So this must be negative 1 also, right? All right. So if you can do it yourself, feel free to pause the video and you can try it out and solve it. Now let's go to base 10 logarithms. So we have here some expressions. And so how do we solve log base 10 expressions? So here on the first one, log of 10, if you don't see the base, this is automatic, that is base 10. So we have log 10 base 10. So what will be the answer? So just count a 0, 1, right? It's 1. Since 10 to the first power is equal to what? 10 to the 1 is 10, right? So the argument is 10. So the exponent is 1, right? So how many times you multiply 10 by itself to make it 10? So just one time, right? How about here? Log of 10,000 to base 10. So once again, you have to count the zeros. 1, 2, 3, 4. So the answer is 4. 10 to the power of 4 is equal to 10,000, right? So the exponent is 4. Okay? How about here? Log of 10 to the negative 25 base 10. So 10 base 10 cancel out. So we ended up with just the exponent, right? So negative 25. What about here? Once again, the exponent is 200. So that's 200. That's the answer. And what about these two? Log base 100 of 10 squared and log 10 to the 5th power base 10 cubed. So how do we solve this kind of log expression? Normally our base must be 10, right? And yet we have here base is 100 and the other one's base is 1000. So how do we solve? Feel free to pause the video and solve it if you know it. Just give it a try. So let's do this. So once again, equate this to x since that's the unknown. So we're trying to find the value of it. So we have here log base 100 of 10 squared equals x. So how are we going to solve for the value of x over here? Right? So we can use the definition of logarithm. 100, the base, exponent x equals the argument. So we have 100 to exponent x equals 10 squared. Right? So 100 expressed in terms of 10, so that is 10 squared, right? And existing exponent is x equals 10 squared. And we have the exponent multiplied together, so that is 10 to the power of 2x equals 10 squared. Now we have the same base. We can equate the exponent, so that is 2x is equal to 2. So here x is equal to 1, right? Divide by 2 both sides. So x is equal to 1. So x here is equal to 1. What about this? So I leave that to you. So I leave this for you guys to solve it as a practice. So what about these two? Log base 10 of 0.0001 and log base 10 of 0.001. So in here, argument 0.0001, that is a fraction, right? And the argument is smaller than the base, so that means the answer is negative, right? Okay, so all we have to do is just count the zeros. 1, 2, 3, 4. So that's negative 4. Right? How about this? Log 0.001. The argument is less than the base, so the answer must be negative. Or the argument is a fraction, right? It's written in decimal form. So that's negative. And all we have to do is count the zeros. 1, 2, 3. So this negative 3. Can we prove that? So let's do it over here. So log base 10 of 0.0001. And we equate this to x, the unknown. So exponentiate both sides. Base 10, right? Since this is base 10, this cancels. So we ended up with just this. So 0.0001 equals 10 to the power of x. So here, this can be written as 1 over 10,000, right? We have 4 zeros, 1, 2, 3, 4. 1, 2, 3, 4. And the right hand side is 10 to the power of x. And 10,000 can be written as 1 over 10 to the power of, how many zeros? 4, right? So you put that to the top, this becomes negative exponent, right? 10 to the negative 4. And right hand side is 10 to the power of x. Here we have now the same base, so we can equate the exponents. So x is equal to negative 4. That's what we have over here. And what about this? Well, this time I leave it to you again. Alright, so you may try pausing the video and solve it. And what about this? Log base 1 over 10 of 10. Did you notice something? The base and the argument are reciprocal. So what do you think would be the answer? It's negative 1, right? Negative 1. So if you see the base and the argument are reciprocal with each other, it means the answer will be negative 1. So let's prove. So log of 1 over 10 of 10 equals x. So exponentiate both sides with base 1 over 10, right? So we ended up canceling this one as 1. So we have 10 equals 1 over 10 to the power of x. Here 10 is equal to, we're putting 10 to the top, so that is 10 to the negative 1, right? From the denominator putting it to the numerator, the exponent will switch to negative from positive, right? So power of x. So this is 10 multiplying the exponent, negative 1x or x. So 10 is equal to 10 to the power of negative x. And here the exponent is 1. Even though it does not show normally, that's considered exponent 1. So base are the same. So x then is negative 1. So flip this. This negative will become negative on 1, right? Or multiply it with negative both sides, right? To get x is negative 1. Let's do natural logs. What is a natural logarithm? Natural logarithm is a logarithm with the base e. Use the base e instead of the common logarithm. So let's say if this is called ln is a symbol for natural log. So ln of y, let's say that is equivalent to log base e of y. And here ln of y, here the base is e. And normally we don't write that e right there, so it will be just an imaginary whenever you take a look at this. That's how we symbolize natural logarithm of y. And so if we have here y is equal to e to the power of x as in exponential form. So how do we convert this into logarithmic form? Since the base is e, we use natural logarithm, right? So we take the natural logarithm on both sides. So ln of y is equal to ln of e to the x. So ln of e is 1. So this brings down the exponent. So we have just x. So ln of y is equal to x. And here the base e is Euler's number. That is equivalent to approximately equal to 2.71828. Here almost all calculations of natural log uses a calculator except when ln of e is used. That means the base is the power of e, ln of e, and ln of 1, where ln of 1 is always 0. As in here, we just use ln of e here. So this cancels each other. So ln of e is equal to 1 and ln of 1 is 0. Since this is base e, so exponentiate both sides, or we have here e to the power of 0 exponent is equal to 1. E to the power of 0 is equal to 1. Going back to this, exponent 0, any number exponent 0 is 1. So you don't need a calculator to solve this too. So we have some examples of natural logarithm expression right here. ln of 5, ln of e to the power negative 5, and so on. So you can use your calculator in solving this, ln of 5. And here, ln of e to the negative 5, you don't need calculator since ln of e is 1. So we ended up with just the exponent, right? So that is negative 5. Here, ln of e to the power of 3, and the coefficient is e to the power of 2. Once again, we don't need calculator to solve this. All we have to do is just cancel this out, right? So we ended up with just e, the coefficient e squared. ln of e is 1, so we ended up just 3, right? So e squared times 3, or 3 times e squared is the answer. What about this? ln of square root of e, square root of e, we can rewrite that as ln of e to the power of 1/2, right? So 1/2, based on logarithmic exponent rule, so we can take this exponent to the front. So that is 1/2 times ln of e, and ln of e is 1, so the answer will be just 1/2. How about here, ln of 3 to the power 1/3? In this case, you can use your calculator, so there's no manual way to calculate the value of ln of 3 to the power 1/3. So I will leave that up to you. Use your calculator. Let's go to change of base formula. So if we have this expression, log of a base b, this can be written as log of a divided by log of b. And here the base can be any number, right? If you put this e over here, that will become log of e, log base e, I should say, is the natural logarithm, right? So it'll be ln of a, and this is ln of b. And in here, this can be written again, log of a divided by log of b. Means we can use base 10 over here, base 2, base 20, whatever, base d, or anything. You can use any number or any letter to make it as a base over here. So that's how it works for the change of base formula. In this case, if you would like to solve this in terms of base 10, all you have to do is just rewrite this log of a divided by log of b. And this must be base 10. So you can use calculator to solve this. If, for example, we have the value of a as, let's say, log of, let's say, 5, and make b as 2. So log of 5 divided by log of 2. You don't need to put 10 over here. All you have to do is press the log in your calculator and 5, then you will get the answer. Simple as that. Now let's go to the properties of logarithms. So we have here number 1, power rule. This is log of a to the power of c base b. This can be written as, if you notice the exponent, we can move the exponent to the front and becomes a coefficient. So this is now c times log of a base b. That's the power rule of logarithm. Next is the product rule. So that means we have here a and b multiplying together. So if we expand this, this is equal to log of a, then plus log of b. And the quotient rule, we have this log of a minus log of b. So we're subtracting b from a, right? Let's go ahead on expanding logarithms. So we have here log of x times y divided by z. So how do we expand this logarithmic expression? So first, those on top or the numerator must be added, and z on the bottom must be subtracted. So this on top that's what we call the product rule, and on the bottom we use the quotient rule, right? So we have to expand the log. So we have log of x, and plus log of y
minus
z. So that means we subtract z over here. So that is log of z. So that's minus. So that's how we expand logs. And so what about this? Log of the quantity a to the fourth divided by b cubed times c to the fifth. So here, log of a to the fourth. And here, the denominator will be, we subtract those. So that is minus log of b cubed. And another one, c to the fifth, that's minus again. So it's log of c to the fifth. And here, putting the exponent to the front, right? So that's the logarithm power rule. So this is 4 log of a minus 3 log of b minus 5 log of c. So that's how we expand this log expression. So what about this? The denominator is y to the 1/2 power. The numerator is x to the 2/3 power. And z to the 1/4 power. So let's start. So log x to the 2/3 plus log z to the 1/4 minus log y to the 1/2. Here we bring those exponents to the front. All right. So that's logarithm power rule. So we have 2/3 log of x plus 1/4 log of z minus 1/2 log of y. So that's how we do that. What about condensing logs? So we have here log of x plus log of y minus log of z. So all the positive sign must go on top and the negative sign goes on the bottom, right? So this is log of x and y are both positive, so that goes on top, so x times y, and then minus just go to the bottom, so that's bottom z. So that's how we condense. What about this? So how do we condense that? So first move the coefficient to the top as the exponent, right? So we have now log of x to the exponent 2/3 minus log of y exponent 1/2 plus log of z exponent 1/4. So now all the positive goes on top, negative on the bottom, right? So this is positive right here. So log of x to the 2/3 and then times z to the 1/4 divided by the one that's negative. So this is y to the power of 1/2. So that's how we condense this expression. So now we're graphing exponential functions, and later we'll be graphing logarithmic functions. So we have here an equation or a function f of x or y is equal to 3 to the power of x minus 2 plus 2. So how do we graph this function? Or what do we need to graph this function? So take a look at our function or our equation. 2 right here is the horizontal asymptote of the exponential function. So horizontal asymptote, that's y is equal to 2. And here, focus on the exponent. So we have here x minus 2, let's equate that to 0. And x minus 2, we take that as 1. And solve for x over here. So x is equal to 2 here. X is equal to, putting 2 on the other side, that will become 3. So values of x, we have 2 and 3 over here. So when x is 2, we have 3 to the power of x minus 2. X is 2 minus 2 plus 2. So 2 minus 2 is 0. So 3 to the 0 plus 2. So this is equal to 1 plus 2. That is 3. So we have y is 3. And when x is 3, so we have 3 to the power of 3 minus 2 plus 2. 3 minus 2 is 1. So that's 3 to the 1 plus 2. It's 3 to the 1 is 3. plus 2 is 5. So y is 5. And so that's all we need to find. So we can plot the exponential function. So horizontal asymptote, y is 2. We have the values of x and y. So we have here now. So we have the horizontal asymptote, that's 2, y is 2. So we have here and we have here the point 2 comma 3, so that is 2 here and 3 comma 3 and 3 comma 5, so 1 2 3 comma 5 1 2 3 4 5. So this is here. So our graph goes from the horizontal asymptote goes up, so it's right here. That goes that way. It's not perfect, but yeah, that's the approximate graph of it. So we graph some more exponential functions. So how do we graph these two equations? So here, if you notice, y, you don't see any positive over here or any number follows the one with the exponent x. So that means the horizontal asymptote is 0. So y is 0. So that's on the x-axis. So here x is positive. That means it's going to the right, to the first quadrant. And y here is positive 3. So that means it's going up. So from here, from the x-axis, almost touching it. So you start from here and goes up. And how about this? X is negative and 3. And you don't see any number aside from this. So the horizontal asymptote is once again the x-axis. So y is 0. So 3 is positive. So y going up, right? So that's going up. And x is negative. That means going to the negative side, going this way. So you start from the first quadrant, going up like this. So what about these two? Y is equal to negative 3 to the power x. Y is negative 3 to the power negative x. So here, once again, the asymptote is the x-axis. There's no other number, right? That follows this exponential term right there. Same thing on here. So horizontal asymptote is the x-axis. Here, y is, that means it's negative 3. That means going down, right? And x is positive, so going this way is positive x, and y is going down, negative, right? So it starts from here, going down, right? What about this? Y is equal to negative 3, negative x. They're both negative, so x going to the negative side and y going to the negative side. So that'll be on the third quadrant. And once again, horizontal asymptote is the x-axis. So it goes this way. Alright. So what about finding the domain and range of the graph of exponential function? So here, based on our graph, the domain of our function y is equal to 3 to the power x minus 2 plus 2. The domain here is the value of x, right? So it starts from negative infinity and to positive infinity. And what about the range? The range is limited by the asymptote, the horizontal asymptote, and here it is 2. Since horizontal asymptote is y is 2, so it's 2 to positive infinity. But it does not include 2, right? So we are now on graphing logarithms. We have here function y is equal to log base 3 of x minus 2 plus 2. So what are the things that we need to know so we can graph a logarithmic function? Alright, so first we have to find the vertical asymptote. So from this, the argument, let's set that to x minus 2 equals 0, and x minus 2 is 1, and x minus 2 is equal to the base. So here, solving for x is equal to 2. So that will be the vertical asymptote. And here, x is equal to positive 3, right? Moving 2 to the right. So in here, x is equal to positive 5. So let's find the values of x and y. Or y, I should say. Since we already have x values over here, so at 3 and 5. Substituting 3 to this, so we have log base 3 of x is 3, so 3 minus 2 plus 2. So here, 3 minus 2 is 1. Log base 3 of 1 plus 2. Log of 1 is 0. So this is equal to 2, right? Since log 1 is 0. So 2, y is 2. And here when x value is 5, so we have log base 3 of 5 minus 2 plus 2. So this is equal to log base 3 of 5 minus 2 is 3 plus 2. So log 3 base 3 is 1. So that is 1 plus 2 is 3. So y is 3. So now we have all the things that we need to know. So we can plot the logarithm. So we have here the vertical asymptote, x is 2 and 2 points in the graph. Okay. We have the vertical asymptote at 2. So we have here. And the 2 points in the graph, 3x and 2y. So 1, 2, 3 and 2y is right here. The other one, 5 comma 3, so that is 1, 2, 3, 4, 5 and 3 is right here. So the graph starts on the side of the vertical asymptote of 2, so going up. So we have here going up that way. So that's how it looked like. And what are the range and domain of this graph? So we have the domain are the values of x. We have it's limited by the vertical asymptote. Vertical asymptote is 2, so that is the domain starts from 2 but does not include 2 and to the positive infinity. How about the range? Range is from negative infinity to positive infinity, right? What about finding the inverse of a function? So let's say we have here an exponential function. The inverse of an exponential function is a logarithmic function. So we try to solve the inverse of this function and graph it. So let's find the inverse of this function. Y equals 3 to the power of x minus 2 plus 2. So first we change all the y into x and change all the x into y. So here y is x right there, and is equal to 3 to the power of y minus 2 plus 2 for the value of y. Okay, so putting 2 to the left, so it will be x minus 2 equals 3 to the power of y minus 2. And here, let's take the logarithm base 3, right? So log base 3, x minus 2 equals log base 3 of 3 to the power of y minus 2. So here, log base 3 of x minus 2 equals log 3 base 3 is 1. So we take down that exponent to be the coefficient of here. So we ended up just the exponent itself. So y minus 2. Solving for y, that is equal to, so log base 3 of x minus 2. And then moving 2 to the left, that will be positive 2. And this is equal to y. Or let's say put y to the left this the same way. Put an equal sign right there. So this is now the inverse function of x from up above. It's equal to log base 3 of x minus 2 plus 2. So what do we need to know to graph the function? So first, let's find the vertical asymptote, right? So vertical asymptote, so let's set this in the argument. So that is x minus 2. let's set that to 0. Then let's set that also to x minus 2 equals to 1. And then x minus 2 equals to the base 3. Here x is equal to 2, so that's the vertical asymptote. Here the value of x is equal to moving 2 to the right, so that's from negative positive, so that will be 3. Here x is equal to moving 2 to the right, that's negative, we become positive, so that's 5. So solving for the y values, so we have here x is 3 and 5 already. So for y, substitute 3 to the equation. So this is log base 3 of x is 3, so 3 minus 2 plus 2. So this is log base 3 of 1 plus 2. 3 minus 2 is 1, so log of 1 is 0, so that's 0, so it's 2. When x is 5, let's find the value of y. So log base 3 of x minus 2, that is 5 minus 2, so that's 3, plus 2 equals log base 3 of 3, that's 1, so 1 plus 2 is equal to 3, so y is 3. Now if we go back to our graph of the exponential function that we did earlier, the first one that we did, we have the values of x and y flipped. X is 3 to the 3 and 5, y is 2 and 3. If we take a look back there, we will find that the numbers are flipped. We have here x values is 2 and 3 and y is 3 and 5. So whenever we have the inverse of the function, we get these values flipped. Since we have that graph of the exponential function already, so we can add this graph for the inverse function of this exponential function. So we have here the vertical asymptote at x is equal to 2. So we have here x is equal to 2. And the 2 points in the graph, 3 and 2. So x is 3, y is 2. So x is 3, y is 2. Here, and then x is 5, y is 3, 1 2 3 4 5, y is 3, it's here. Now if we integrate here the graph of the logarithmic function, so we have it here, it follows the vertical asymptote from x is equal to 2 and going up. So we have here and follow these 2 points. So that will be the graph of the logarithmic function. So if you notice, this is direct reflection of the exponential function, right? And the graphs flip over a 45-degree line. Y is to x that passes through the point of origin. So from here, so that is y is to x. So it's a perfect mirror. All right, and so for the graph of the logarithmic function, what are the range and domain? So the domain here is limited by the vertical asymptote, so that is 2 to infinity. And the range is equal to from negative infinity towards the positive infinity. And of course 2 here is not included because the graph never touched the vertical asymptote. The same thing on the graph of the exponential function. It never touched the horizontal asymptote. Y is equal to 2. Okay. Now let's start solving logarithmic equations. So how do we solve this? Logarithm of 9 base x equals 2. So here let's use the definition of a logarithm. Base is x and exponent is 2. So we have base of x to the exponent 2 equals the argument. So here to solve for x, we take the square root of both sides of the equation, right? So we get rid of the square and the radical. We have here positive negative square root of 9. So x is equal to positive negative 3. So we have two values, that's x is equals positive 3 and negative 3. And if we take a look, verify our answers, negative 3 could not be in the argument, right? Since logarithm of negative number is not allowed. So our answer is x positive 3, and negative 3 is the extraneous solution. So what about this? Logarithm of x base 9 equals 2. So here we raise both sides of the equation to base 9. So 9 to the power of log base 9 of x equals 9 to the power of 2. And here 9 to the power of log base 9 are inverse functions. So this cancels out. So we have x is equal to 9 squared. So this is 81. So what about this? Log of x minus 5 base 5 equals 2. Here we can solve this equation in two ways. First one is going to be using the exponentiation, right? Like in here, exponentiate both sides of the equation. So in here we can raise both sides of the equation to base 5, right? So we do that. So we have now log base 5 of 5 cancels out. So we have x minus 5 equals 5 to the second power, or 25. Solving for x is equal to 25 plus 5. So x is equals to 30. And the other way to solve it is by using the definition of logarithm. So we have here 5 to the power of 2 equals x minus 5. So we have 5 squared equals x minus 5. And solving for x, putting negative 5 to the left, so we have 5 squared is 25 plus 5. From negative become positive equals x. So 25 plus 5 is 30. So that's the value of x. How about this? Log base 3 of x plus 2 plus log base 3 of x minus 2 equals 4. So here we'll be applying the rules of logarithm. One of the properties, we can condense the logarithms, right? Since we have here plus, that means we're using the product rule. So we have here log base 3 of x plus 2. So that's the one. And times x minus 2 equals 4. From here, we exponentiate both sides of the equation with base 3, right? So base 3. So this cancels, and we have x plus 2 times x minus 2 equals, and we have here 3 to the 4th power is 81. So we FOIL these two factors right here. So that is x squared plus 2x minus 2x minus 4 equals 81. So 2x minus 2x cancels, so we have x squared minus 4 equals 81. Solving for x, so x squared is equal to, that's putting negative 4 to the right, so that's 85. So by taking the square root of both sides of the equation, so we're canceling the square and the radical sign, so we have x is equal to positive negative square root of 85. So we have two values of x. This is equal to positive square root of 85 and negative square root of 85. And we look back to our equation. If we have a negative in the log, we cannot use that answer of x. That's here is negative square root of 85. And if we put this in our log, here, negative square root of 85, and then this negative 2, the argument will be in the negative. So negative 85 is not accepted. That's an extraneous solution. So we have just the value of x as positive square root of 85. What about this? Log base 4 of x plus 2 equals log base 4 of 3x plus 1. So here we have the same base log base 4, so we can cancel those. So we ended up with just x plus 2 equals 3x plus 1. So let's solve for x. So we have 2 minus 1 equals 3x minus x. So 1 is equals to 2x. So x is equals to 1/2. We have another one. ln of 2 minus x equals 3. So we have natural logarithm over here. So what should we do? So we raise both sides of the equation to base e, right? Since this is natural logarithm. So we have e to the power of ln and e to the power of 3. So e to the ln cancel each other. So we have 2 minus x is equal to e to the power of 3. So for x, so x is equal to 2 minus e to the power of 3. Solve some exponential equations. 3 to the power of x is equals to 4. So here let's take the natural logarithm or common logarithm. Either way. So let's use logarithm to base 3. Since it is base 3, 3 to the power of x equals log base 3 of 4. Putting down the x as a coefficient, that's logarithm power rule, and log 3 base 3 is cancelled. So we have x is equal to log base 3 of 4. Final answer. Or the same way, x is equal to log of 4 divided by log of 3. And this is base 10. So you can compute this by using your calculator, right? And this is to be solved the same way by using natural logarithm. So let's take the natural logarithm of both sides. So that is ln of 3 to the power of x equals ln of 4. So once again, take down the exponent as x on the front. So we have x is equal to ln of 4 and divide by ln of 3. So that's the same. Since if we convert this into natural logarithm, this is gonna be base e. So this is the same way written as ln of 4 divided by ln of 3. So that's the same way as that. How about this? E to the power of 2 minus x equals 3. So how do we solve? Since this is base e, so we'll be using the natural logarithm. So ln of e to the power of 2 minus x equals ln of 3. ln of e is 1. So you can take down the exponent as a coefficient in the front. So we have 2 minus x equals ln of 3. So for x is equal to 2 minus ln of 3. By using your calculator, we can calculate this as this is approximately equal to 0.901387. Sometimes you might be given this kind of equation. 27 to the power of x plus 2 equals 9 to the power of 2x plus 1. So how do we solve this kind of exponential equation? We can convert the base to the same base, right? 27 and 9 can be converted to base 3. So we have 27 is 3 cubed, so 3 to the power of 3 times x plus 2. That's the same exponent. Equals 9 is 3 squared. 3 squared to the power of 2x plus 1. So here, multiply the exponents, right? And since we have the same base, that means we can equate the exponents. So we have here 3 times x plus 2, that is 3x plus 6 equals 2 times 2x plus 1, that's 4x plus 2. And so for x, so we have putting 3x to the right and 2 to the left. So we have 6 minus 2 equals 4x minus 3x. So 6 minus 2 is 4 equals 4 minus 3, that's x. So that's the final answer. And so this will be the last exponential equation to solve. So we have here x to the power of x divided by 2 equals 36 to the power of 18. So how do we solve this kind of exponential equation? So here we cannot use the logarithm to solve this equation. So in this case, let's just do it this way. The base is not the same as its exponent. the base is x, the exponent is x over 2. Likewise, on the other side, the exponent is not the same as its base. Since we have here on the left side x divided by 2, our purpose then is to make the base the same as its exponent, right? So if the base is x, the exponent must be x the same way, right? So what are we going to do? So we need to get rid of the denominator of that x, of the exponent, right? So in that case, we'll be raising the whole equation with exponent 2 to get rid of that denominator of the exponent, right? So we have x to the power of x over 2 and multiplying the exponent with 2. So that's multiplied by 2 equals 36 raised to the power of 18 times 2 is 36. So now if you know this, the right hand side, the base is the same as its exponent. How about on the left side? So you can see that we can cancel 2, right? So we ended up on the left hand side, it will be just x to the exponent x. Right hand side, 36 to the exponent 36. So by comparison, we can say that x is equal to 36. So that is the final answer. And so that's all for now, and thank you for watching. I will see you on the next videos. Have a great day, everyone. Bye-bye. Take care.